बताना चाहता हूँ कि रियल गैसेस कौन सी होती हैं। याद रखना है, हीलियम, नियॉन, आर्गन, क्रिप्टॉन, जीनॉन एंड रेडॉन। यहाँ पर क्लोरीन एंड फ्लोरीन, ऑक्सीजन एंड नाइट्रोजन एंड हाइड्रोजन। कितनी गैसेस हो गई टोटल बेटा? काउंट करो। 1 2 3 4 5 5 11 गैसेस ऐसी होती हैं बेटा जो रियल गैसेस होती हैं।
और बाकी गैसेस आइडियल होती हैं।
बाकी बाकी मतलब ये समझो, बाकी वो आइडियल की तरह, रियल की तरह भी एक्ट नहीं आ पाती है। ठीक है, वो मतलब बहुत ही दूर होती हैं ग्राफ से, ऐसा। ठीक है,
मेरे को एक चीज मतलब बेसिकली जो ये गैसेस हमने अभी लिखी हैं, तो ये सारी गैसेस मतलब ये मतलब बॉयल्स लॉ चार्ल्स लॉ को नहीं फॉलो करती है एक तरीके से।
हाँ, बॉयल्स लॉ को, चार्ल्स लॉ को 100% फॉलो नहीं करती, इसीलिए रियल गैसेस हैं बेटा। और ये आइडियल को टेंड तो करती है बट एग्जैक्टली नहीं होती। ठीक है ना?
ऐसा
अब बेटा एक चीज आपको पता होना चाहिए, मैं आपसे ये बात शेयर भी करूंगा और आपको पता भी है। नॉर्मली हम लोग जानते हैं कि जो वी ऑफ आइडियल होता है, वॉल्यूम ऑफ आइडियल गैस, वो 1 मोल का 22.4 लीटर होता है। यस और नो?
ऐसा
बहुत हम अच्छे से जानते हैं, मैंने बताया भी था आपको, आप पहले से ही इनफैक्ट जानते थे। लेकिन जो रियल गैस होते हैं, जो रियल गैस होते हैं बेटा, इनका वॉल्यूम या तो बेटा 22.4 से कम होगा, या बेटा 22.4 से क्या होगा, ज्यादा।
बेसिकली 22.4 नहीं हो सकता।
हाँ,
और तो
एग्जैक्टली नहीं होगा। और अगर ऐसा होगा तो आपको पता है बेटा, यहाँ पर गैस को यहाँ पर कंप्रेशन किया गया होगा, गैस को कंप्रेसिव फॉर्म में होगी, और यहाँ पर बेटा एक्सपेंशन फॉर्म में होगी। ये बात समझ में आती है आपको?
यस सर।
दूसरी चीज, जो आइडियल गैस की सबसे इंपॉर्टेंट कंडीशंस होती हैं, वो क्या होती हैं बेटा? यहाँ पर दो कंडीशंस बहुत होती हैं कि मॉलिक्यूल्स कोई भी स्पेस ऑक्यूपाई नहीं करते, इसका साइज इतना छोटा होता है कि कोई स्पेस ऑक्यूपाई नहीं करते हैं। द एटम या एटम कर सकते हैं, occupies any spaces। और दूसरा बेटा क्या होता है, दूसरा ये स्पेस ऑक्यूपाई नहीं करते, और दूसरी चीजें क्या होती है कि उनके बीच कोई फोर्स ऑफ अट्रैक्शन भी नहीं होता है। मतलब जो एटम होते हैं, देयर इज नो फोर्स ऑफ अट्रैक्शन। ठीक है, एटम
यस
के बीच बेटा कोई फोर्स ऑफ अट्रैक्शन भी नहीं होता है। एग्री कर रहे हैं इस बात से?
यस सर।
चलिए, बहुत बढ़िया बात है। तो ये बेटा मैंने आपको बताई रियल गैसेस की बात बताई। अब हमें ये देखना है कि भाई ये कब ऐसा होता है, कब क्या होता है, तो हमें ये एक्चुअली चीजों को इम्प्लीमेंट करना होगा। और रियल गैस के लिए हम यहाँ पर एक नया फार्मूला डिराइव कर देते हैं, पीवी इज इक्वल टू एन इंटू जेड आर टी। यहाँ जो जेड होता है बेटा, वो पीवी अपॉन एन आर टी होता है। ये जो टर्म आया है नीचे वाला, ये हमेशा कांस्टेंट है, ये आइडियल से आया है बेटा। प्रेशर वॉल्यूम रियल होते हैं, वो रियल है, कभी चेंज हो सकते हैं, ये रियल होता है। तो मतलब बेटा, ये जो जेड की वैल्यू है, ये 1 हो सकती है, ये हो सकती है, ये 3 केस बन सकते
दैट इज ग्रेटर देन 1।
हैं। ठीक है, ग्रेटर देन 1,
और
इक्वल 1 और
एडवांस है तो फिर गैस आइडियल होगी।
हाँ, यस यस। एक बार देख लीजिए आप अच्छे से।
यस सर देखिए।
तो आज मैंने आपको बेसिकली, अगर मैं बताऊं क्या क्या बताया, गैस लॉ में ही आपको मैंने गे ल्यूजिक, आइडियल गैस, डाल्टन्स लॉ ऑफ पार्शियल प्रेशर, डेंसिटी वगैरह के ग्राफ समझा है। और डेंसिटी को रिलेट करना एक्चुअली में बताया मैंने, और बहुत सारे क्वेश्चन भी कराए। फुली बेटा मैं कुछ क्वेश्चन आपको और भेज दूंगा, जैसा कि मैंने आपको रिक्वेस्ट किया है आपसे कि आपको भी अगर कोई एक बुक आती है पियर्सन की, त्रिशा पब्लिकेशन की आईआईटी फाउंडेशन सीरीज, इफ यू नो।
जैसे वो बुक पे बस है, वो अभी मेरी आई है राजा, कल तो मैंने उसको पढ़ना स्टार्ट कर दिया।
तो आप ना वहां पर स्टेट्स ऑफ मैटर आपके पास होगा, या आप एक काम करना, उसका फोटो क्लिक करके उसका टेबल ऑफ कंटेंट मुझे भेज देना, क्योंकि मेरे पास वो बुक काफी पुरानी
वो
होगी।
तो बॉयज लॉ चार्ल्स लॉ तो एक्सप्लेन किया एक चैप्टर में, तो वो मैंने पढ़ा था कल ही तो। और उसमें और भी मैंने बहुत सारी अलग अलग चीजें, तो अगर कोई डाउट्स होंगे तो आपसे क्लियर कर लूंगा।
नहीं नहीं, उसका मुझे टेबल ऑफ कंटेंट आप भेज देना, और चैप्टर 1 का अगर एक्सरसाइज का पीडीएफ बना के आप भेज पाओ, मुझे थोड़ा सा काम मेरा ज्यादा रहता है, तो आप भेज पाओ अगर, तो मेरे लिए भी और भी अच्छा रहेगा। तो खाली समय में जब आपको
यस
खाली बैठे हो तो 2 मिनट का काम है, वो फोटो क्लिक करके भेज देना, ठीक है?
यस सर।
इज एनी प्रॉब्लम?
नो सर।
चलिए फिर मिलते हैं बेटा, थैंक यू।
बाय सर, थैंक यू सर।
Hi, sir. Sorry. I just finished another class.
No problem, beta. It's happened.
So can you see me?
No, you can. I can.
Okay.
So how are you, beta?
Yes, I'm fine. How are you?
I'm also fine, beta. Are you people safe?
Yes, sir. Yes, everything's fine.
So your COVID test is negative, I think.
Yeah, it was negative. So
Thanks
everything
God.
is fine.
Okay.
Yes.
So, beta, what we read in previous classes?
So we did periods in groups in the modern periodic table and in mostly's periodic table.
Okay.
And the modern periodic table, we learned that it's the modified version.
Okay.
So yeah, we took all, and there are in the modern periodic table there are 18 columns and there are 18 columns and 7 rows.
Mm-hmm.
So and in mostly periodic table there are 8 columns and 8
no
columns
problem.
and 8.
No problem. So, beta, my first question is, who gave the modern periodic table? Who researched actually? which?
I'm not sure. I forgot.
But tell the name of that scientist.
So I'm not sure. I forgot.
It was Henry H. Moseley.
Oh, okay. So I meant Mandalay's periodic table. I mixed up between both of them. Okay.
Can you give the law of modern periodic law? Can you give the modern periodic law actually?
Yes. So the modern periodic law is that physical and chemical properties of the elements are in the periodic functions of their atomic number.
Very good. Very good. Means you understand that all the elements are arranged as according to their atomic number, isn't it?
Yes.
So, Varuska, tell me if you have any element having atomic number 16, tell me the group and period of you are having 16, atomic number 16.
Sulfur. Is it sulfur? And it's in I know it's in group 16. I'm not sure which period.
Actually it is 16, so it is 28 comma 8 comma 6.
Yes.
So if 286, so we can say it is in third period because there are 3 cells.
Okay. So.
Got it?
Okay. So, yes.
So tell me the period of having atomic number in element 18.
Of 18, it's Argon.
Yes. No. It is not mandatory to learn the name of this element. Just tell the period and groups.
Okay. So the period is for Argon. For 18, it's period group 18 and period 4.
How?
Sorry, period 3.
Yes, very good. Means beta 2 comma 8 comma 8. So its period is, you are good, very good. And group is 18. So basically, if 8 is in the outermost cell, so period group is 18. Okay.
Okay.
Now, beta, today we are going to discuss some another things. First thing which I want to discuss with you, that is your magic number.
Okay.
Magic number. Actually, beta, magic number tells us about the number of elements in a particular period.
Okay.
Number of element. It is beta. and its value is comma 8, comma 8, 18, comma 18, comma 32, comma 30. These are the numbers 2, 8, 8, 32, 32. Means beta in first period there are only 2 elements. In second period 8, then 8, then 18, then 18, then 32, and then 32. Okay.
Okay.
If you just add, if you please add these numbers, if you add this number, how much you got? Please add these numbers.
So it'll be so I add the 2, 8.
Yes.
Okay. So it'll be 2, 8, and then it's 16. Or so.
No. 2, 8, 18, 18, 30.
Oh, okay. So 2 plus 8 plus 18 plus 18. So that's 46, and then 32. So that's 78 plus another 32, right? So 110. It's 110.
No, it is 118.
Sorry, 100. Okay.
Go 8 to 10, 10, 8, 18, 18, 36, 54, 86, and 118. 118.
Okay. Okay.
So firstly, beta, the first question,
Yes.
if you want to write in your notebook, you can write these are the magic number. Okay. These are the.
Okay.
You are making notes, beta?
Yes, I am.
So basically, from today, I will provide the recording of last class. I will send the recording. Actually, I didn't send. I forget it.
Okay, sir, no problem.
Okay, so did you understand all these things?
Yes, sir.
But first thing, another thing, which this is first and second group, and in first and second group, there are basically metals.
Okay, sir.
Metals. In 13 to 18 group, this is basically, these are non-metals, and in this third group to 12 group, there are transition metals or transition elements. You know, Varuska, what is transition elements? You know what is transition element?
No, sir, it's like the I forgot.
But transition, what is the meaning of transition?
So it's like a change, like a gradual change.
Very good. But transition means change in their valencies.
Okay.
That means, beta, these elements show different valencies. Like if you talk about iron, it shows +2 and +3 as well.
Okay.
Okay, so transition elements show different valencies.
Okay, sir.
Got it? But, what are these elements? Tell me the name of these elements, as I told to you in last class. Can you define?
It's there there
Yes, beta.
So is it going to be alkaline?
No. There are lanthanum and actinum.
Oh yes, yeah.
There are lanthanum and actinum, as I told to you, and these are radioactive element. You know,
okay, yeah.
Radioactive element, as I told to you, these elements basically emit alpha, beta, gamma rays.
Okay, so okay.
Now we come to what we have to discuss now. Basically, beta, this table is bifurcated into 4 blocks. And what are the common things in if elements which are present in the same group? If we talk about this first group, what are the common things? If we talk about hydrogen, it is 1. Lithium, it is 2,1. Sodium, it is 2,8,1. In the way, if we talk about beryllium, it is 2,2. Magnesium, it is 2,8,2. So all these elements which belongs to same group are having similar electronic configuration. This is 1, this is 1, and this is 1. This is 2, and this is 2. So what we can write here, all the elements which are having similar electronic configuration belongs to same groups. It is clear or not?
Yes, sir, it's clear.
Okay, I think you want to note it, or should I proceed?
Yes, sir. Yes, sir, I want to. I'll just note it down 1 second. Okay, so I finished.
Okay. Now, beta, let's say if any element having 7 electron in their
Yes.
outer shell,
Yes, sir.
find the group of that element. If any element having 7 electron in the outermost cell, find the group of this element.
Okay, so is it it's so it will be group
Group it belongs.
So
To which group beta this belong?
So group 17.
Very good. Group 17. Okay.
Yes.
Okay, got it. Got it.
Okay.
Now, element an element of group 2 combined with elements of group 17. Find the formula. Okay. And this is your element X. This is your element Y. Now find the formula of this.
So it's an element of group 2 and it combines with so it's
Let's say.
So it's an element of
If
group 2. So
yes, Vanuska, please wait, beta. If elements belongs to group 2, definitely its valence is 2, isn't it?
yes, sir.
Because all the elements having two electron in outermost present in the group 2, so the valency of X is 2. And what is the valency of Y here?
Okay. Yeah, so it'll be valency by 17.
Yes, 17 group valencies. What is the valencies of 17 group?
So it's for 17 it's 3.
No. If you talk about fluorine, you know fluorine belongs to which group?
Yes, fluorine the
2,7.
yes.
So fluorine, the valency of fluorine is what?
So it's
Beta. Yes, you are telling something.
yeah, so valency of fluorine is 1.
How is it 1?
Because it's missing, like, so to complete its octet, it needs 1 more electron.
Absolutely, you are fine. You are very good. Now you got the concept. Then what is the formula? Valency is interchange. Formula is x1 by 2. Formula becomes x by 2. Isn't it?
Yes.
Got it or not?
Yes, sir.
Okay. Now, the another question. Do you want to note this question?
Yes, sir. 1 second.
Beta, Vanuska, which chapter you are doing in school?
So analytical chemistry.
Okay, very good. So classes is going on which platform?
So on Teams, but so we have school on, like, we go to school on Sunday, Wednesday, and Thursday, and then Monday and Tuesday it's online.
Okay, so in which platform they take the classes?
On Google Teams. Sorry, Microsoft Teams. Okay, sir. I can.
Got it, beta?
Yes, sir.
Okay. Okay, now let's say the element of group 1 reacts with elements of group 16. Then find formula. And let's say element group 1 having X and element having group Y is Y. Okay, then 2.
Okay. So it will be so we take for group 1 valence is 1, right? So and then group 16 it's so it's X as 1 and then Y as
Yes, what is the valence of Y?
So Y will be so I'm not sure, it will be
Because if you talk about group 16, you know, group 16 is oxygen family, isn't it?
yes. Yes.
So if you talk about oxygen family, it is 2, 6, and it needs only 2 electrons to complete its octet.
Yes. Yes.
Valence is 2.
Okay. So
X and Y. X is 1, Y is 2. Now formula become X.
okay. Okay. So okay. So
Any problem?
no, sir, no problems. I understood now.
Okay. Should I rough it?
Yes, sir.
Now, beta, we come to now the another thing. Do you know Spdf electronic configuration, Varaska? Do you know?
No, sir.
Okay, no problem. Can you see this whiteboard, beta? Exactly.
Yes, sir, I can.
Okay, now, beta, now we are coming towards the Spdf electronic configuration. You know, Spdf are basically shell. Sorry, subshell. You know, there are various shells like, you know, K cell, L cell, M cell, and N cell. You know?
Yes, sir.
You know K element cell?
Yes, sir.
So in K cell, L cell, M cell, and N cell. In K cell, beta, there are one subcell that is. In L, there are two subcell S and P. In M, there are three subcell S, P, and D. And N, there are four subcell S, P, D, and F. There are four subcells, isn't it?
Yes, sir.
So, Varuska, one question from my side. Can you tell how maximum electron in K cell? How many?
2. So 2.
Very good. L
And 8.
M.
And 18.
Very good. And N.
32. Yes.
Okay. So if there are two electron in K cell, definitely we have to accommodate two electron in S subcell.
Yes, sir.
If S is 2 in S, 6 in P, isn't it?
Yes, sir.
And 2, 6. How many electron in D? Can you tell?
So there'll be 2, 6, and then so shouldn't it be like 2, 8, and then 8?
But we have to make 18, and only we completed 8 now. So how many electron in D now?
So 10. So why isn't it 2, 8, 2, 8, 8? We wrote 2, 6, and 10. Why didn't we write 2, 8, 8?
Actually, beta, actually, because in subcell we have to accommodate these subcells, that is Spdf, and because we know that in K, L, M, N the electron are fixed. If we write something like what you are saying, then electron can increase, that what we actually want. Because if you want 2,8,8, then electron will become how many electron? It will become 18 beta. But in p cell only 6 electron can be accommodated, but you are writing 8, so it is wrong here.
Okay, so
Okay. So in F, how many electron we can accommodate in F?
so it'll be so it'll be 18.
In beta F subcell, just count.
So it'll be 14.
40.
Sorry, 14.
Okay. So you know beta that it is your first cell. So furnace, it is your second cell, so 2s and 2p. It is your third cell, so 3s, 3p and 3d. It is 4s, 4p, 4d and 4f, isn't it?
Yes, sir.
So 4 is nothing but 1 is number of shell. This 1 represent number of cell, is cell number.
Okay.
Beta, if we fill the electron, if we write the electronic configuration, we have to write in according to energy. What is exactly means by energy? It means that we have to fill lower energy cell first and then higher energies. Okay, let's any element belongs to the I think first group or first period, then it will be filled first, then another things we have to do. So what is the order? Let's write the order beta of these. That is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10 and 4p6. There is a one exception beta. If you write the one exception, the energy of 3d is more than that of 4s. This is one exception beta. So we have to write 3d after and 4s before. Okay?
Yes, sir.
Okay, isn't it?
Yes, sir.
Please note it down beta. Then Urska, can you tell the atomic number of sodium? I think you got it is 11.
Yes, sir. It's
So
11.
it is 2,8,1, isn't it?
Yes, sir.
So if you write in SP manner, it is 1s2, 2s2, 2 and 3s1. Because you are having your notebook, and if you write the order, that is 2, 2, 4, 6, 4, 10 and 10 plus 1, 11, isn't it?
Yes.
If you write the electronic configuration of chlorine, it is 2, 8, 7. So how can we write in SP manner? It is 1s2, 2s2, 2p6, 3s2, 3p5, isn't it?
Yes, sir.
If you add these numbers, you will find it is 17. Okay.
Yes, sir.
Then beta, one assignment for you. Please write the atomic electronic configuration of argon.
Okay, sir. Okay. So right now or
Right now.
okay. Mm. So so Argon's atomic number is 18.
Yes.
Right? So its electronic configurations are 288.
Yes, very good. But SPDF manner you have to write.
Okay. So so it'll be like 1s 1s squared, like 1s2
1:2.
1s2 2s2 and 2 2p6
Very good.
and 2p6 and 3s2.
Okay. 3p6.
Very
good. 3p6. Okay, got it?
Okay. Yes, sir.
Just do one again. You have to write the electronic configuration of manganese, that is 25. Okay, right. So one thing to tell you, beta, because it is not necessary to write first 2,8, something. Just start with SPP. So first we have to write 1s2, then 2s2, then 2p, then 3s2, then 3d. Sorry. After 3s2, we have 3p6, then 4s2. How many electrons till we completed?
Yes. Yeah. So yes, it'll
How
be
many electrons
completed.
we filled now?
So there are 4, 10, 80, 20. So
Yes,
we
beta.
5.
5. So 5 will be filled in 3d5.
Yes.
Okay, got it? Got it?
Yes, sir.
As last we do, this is 3D. So after 4s, you have to fill 3D. Okay. Then if you talk about zinc, beta, there is a background noise. Very.
Sorry, can I just have a minute to close my door?
Okay.
Okay. Yes, sir. Is it all right now?
No. Sorry. Thank you, beta. It's all right now. Now 30.
So it'll be so it'll be 1s2.
Beta, first write in your notebook, then tell.
Okay. Okay, so it's 1s2, 2s2, 2p6, 3s2, 3p6, and 2d10 and 3s2, 4s2. Yes, so that's
And at last 3d10, you got 3d10.
yes, sir, 3d10.
Very good. So what is the conclusion of this writing this SPDF beta? Because as we know that, just let me share one thing.
Okay. So 3.
Okay. So what is the conclusion of this concept beta? Like if any element in outermost cell you find S. If any element in outermost cell you find P, D or whatever F beta, then it belongs to that particular block. It is your S block, as you know. This is your S block. This is your P block. This is your D block. And this is at last, this is your F block.
Okay.
Isn't it?
Yes, sir.
So with the help of these particular electronic configuration, we can find out which blocks it belongs. Because beta in S block there is only and only metals, as you know very well. I stated previously also. In P block generally they are non-metals.
Yes.
In D block there are transition metals.
Yes, sir. Yes.
So tell me beta, an element having atomic number 90. Tell me which blocks it belongs to. An element having atomic number 19. Tell me to which block this belongs to.
So 19 would be the first period, group 4. So
You just reverse the data. Fourth period and first group. You told.
oh sorry, a fourth period and first group.
Okay, got it. And S block.
Yes.
Can you write the electronic configuration of this element?
Of 19 in the SPDF form.
Yes, in SPDF form, exactly.
Okay, so Sir, so it's 1s2, 2s2, 2p6, 3s2, 3p6, and 4s1.
Okay, okay, very good, very good, very good. You got, I think, all the things, beta. One thing I want to write here. Are you agree with this? I'm writing a statement. All the elements belongs to same group having similar chemical properties. Are you agree with this statement? Because in ICSE there are some statement of true and false can be asked. You know.
Yes.
So this
Yes,
statement is true or false?
Yes, sir, it's true.
Why?
So all the elements belong to the same group, and they have similar chemical properties. So
why it is true?
So because like all like
So tell me, Varuska, chemical properties based on which property? Chemical properties based on which thing? Actually, if you talk about like lithium, if you know lithium, it is 2,1. Sodium, it is 2,8,1. Potassium, it is 2,8,8,1. So you know.
Yes.
There is one electron in outermost, isn't it?
Yes.
That means, beta, that means they are having same valencies.
Okay.
If they are having the same valencies, then we can say they are having the similar chemical properties, because chemical properties based on the valencies.
Okay.
Okay. So I think you can write, if you don't think, beta, chemical properties is actually based on the valencies. And valency is based on electronic configuration.
Okay. Okay, sir, I wrote.
Yes, you completed, beta?
Yes, sir, I completed.
Okay. So, what do you agree about the physical properties? Are physical properties same?
Yes, so the physical properties are different from the chemical properties.
No. My question is, yeah, the element belong to the same group. Are they having the same physical properties as well as they
no, so they have the same chemical properties, but not the same physics.
Very good. They are not having the similar physical properties, but they are having the similar chemical properties, because the physical properties is depends upon the size, the appearance, the look, the other things. And if we move down to the group or across the group, beta, definitely these properties have been changed.
Okay.
Isn't it?
Yes, sir.
Okay. Now, tell me one drawback of this table. Tell me one drawback of this table. Do you agree? One drawback you find? First is place of hydrogen. Place of hydrogen. Do you know in this periodic table, beta, hydrogen is placed in this place, isn't it?
Yes, sir.
So its valency is H is, so its valency is obviously 1. But if you talk about this fluorine, beta, its valencies also has 1. That means, beta, hydrogen can form either H plus or either H minus. If it form H plus, it behave like lithium plus. If it form like H minus, it belongs like Cl minus, F minus, something like this.
Okay, sir.
So hydrogen is behaving like 2 different groups. It is behaving, it's showing the properties of group 1 as well as group sequenting. So the place of hydrogen is not fixed still yet, we can say, because it can show the hydrogen plus ion as well as it can show the hydrogen plus H minus ion, isn't it?
Yes, sir.
So the place of hydrogen is very, very ambiguous still now. So the place of hydrogen is very, very ambiguous till now, and this is the thing, isn't it?
Yes, sir.
Okay. Second one, no place for F block. There is no place in this table which rectify or verify or correctify the F block element. These are F block element.
Okay.
Inside the periodic table, there is no place because they are resided outside the table. But genuinely, they should be present in the periodic table. Are you justifying with this? Are you justifying this?
Yes, sir. So it's yes, sir, I'm understanding. Yeah.
Because it should be present inside the periodic table, but they are resided. These groups are resided outside the periodic table. They should be present over here.
Yes, sir.
So there are drawback. First is the place of hydrogen. So number 2, no place for F block element. That is lanthanum and actin, isn't it?
Yes, sir.
Okay. So do you want to note it?
Yes, sir.
बेटा आपका इसके बाद कोई दूसरा क्लास है क्या?
No, sir. This is my last class for today.
You have only one class today, na?
No, so I had 2 classes. I had physics before this and now chemistry.
Physics you read from, I think, Vikas sir.
Yes, sir.
Okay.
Yes, I finished writing this, sir.
Okay, okay. From when beta you are studying from, Vikas sir? From client?
No, sir. Just recently I started in 10th.
How many chapters sir completed?
He finished the first chapter. So he's doing sound now.
Okay, okay. So completed or not this one?
Yes, I finished.
Now beta, now we have to come the slide. Okay. Beta, did you purchase the book?
No, sir. My mom's going today to get the book because we're buying it from the store. We can't we're buying it from India, then it takes a while to come.
Okay.
So we'll get it today.
Okay, okay. No problem. Now,
Yes.
now what we read actually, the Newland law, Triad law, Mendeleev old table, Moseley's new table, some correction and rectification. Okay. Actually, this table accommodate the 8 elements. Yes, beta, please.
So I can't hear you right. So I can't hear you. Please.
Now, is it okay?
Yes, it's fine now.
So, this table is made actually for 118 elements beta. We discuss S block, P block, T block, and F block. Okay. One question, last question, I think I want to ask with you. An element having atomic numbers 21. Okay.
Yes.
Can you tell me which block or which group it belongs to?
For 21.
For 21, firstly you have to write the electronic configuration according to Spdf. That after that you are able to do this.
So for
Yes, please.
For 21.
Firstly, write the electronic configuration. My suggestion
Okay.
is write the electronic configuration.
Okay. So we start with so 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, and 4s2. Yes.
Can you repeat?
Yes, sir.
1s2,
1s2, 2s2, 2p6, 3s2, 3p6, 3d1, and 4s2.
Very good, very good. So at last, beta, you are filling D because your D is completed. Actually, in the maximum electron can be 10, and you are having only 1 electron in D block, isn't it?
Yes, sir.
So which block which belongs to D block, isn't it?
Yes, sir.
D block. And D block is starting from which group? Can you remind yourself it's from which block it starts?
So from group 3.
Yes, beta, group 3. So
yes.
Group 3, 1 second. It is your D1 and it is your D10. It is your D2, D3, D4, D6, D7, D8, D9.
Yes.
It is D1. So it belongs to third group, isn't it?
Yes, sir.
So is there any problem in your basics?
No, so I think it's fine now.
One assignment for you, beta. you have to write the advantage of triad rule, disadvantage of triad rule, is advantage of Mendeleev table, disadvantage of Mendeleev table, and advantage of modern periodic table and disadvantage of modern periodic table. Okay.
Okay, so.
And this is your homework. When you completed the homework, be back so I can check. Okay.
Okay, so disadvantage and advantages of Mendeleev's periodic table and the modern periodic table.
Yes, only two, Mendeleev and modern. Okay.
Okay.
And place a separate book for chemistry. You made a separate book for chemistry, separate note.
Yes, sir. Yes, sir. I use a register.
Okay.
For my notes.
When you got the book, beta, please ping me or text me. Okay. So that
yes, sir, I will.
I can give the more assignment to you. Okay.
Okay.
So thank you, beta.
Sir. Okay, thank you, sir.
Welcome.
Thank you, sir.
Welcome.